All right, this is m25 vectors question number 5. A has a position vector 5, 1. B has a position vector 1, -3, etc. You are asked to sketch or otherwise write these column vectors. So I'll draw the sketch, or get you started on drawing the sketch, and lead you to what's needed here. So vector AB. So first thing we'll do is draw these position vectors, which all will initiate at the origin according to the definition of a position vector. So here goes. Use a black marker. A has position vector 5, 1. So start at the origin. That goes 5 right, 1 up. So I'll draw it right there. B has a position vector 1, -3. So it's 1 right, down 3, 1, -3. And the last one, C, -2, 4, -2, 4. Okay, so I want to label what we've done here. All right, so A goes here, 5, 1. B is at 1, -3. So this would be C. So back to the question. Find A to B. Well, how can we go from A to B? Well, let's draw a green line taking us from A to B. Remember, we're starting here at A, and we're going to B. There's a couple ways of looking at this. So let's just start with the diagram. To go from A to B, we have gone 1, 2, 3, 4, 4 units left. So that would be left 4, -4 for the x component. And then we have gone down 1, 2, 3, 4 for the y component. That's one way of determining the resultant vector A to B. Okay. There's a second way to do it, though. I might as well show you this now, because it will prove productive in later assignments. We could set up a vector equation. So to get from A to B, notice that you could go from A through O to B. So follow my red line here. I could go from A through O to B and connect these vectors from tip to tail. And that is another way of getting from A to B. So what we could do is say, if I take position vector A to O, not A to B, A to O, A to O, and add to it the O to B, that takes us from A to B. So what is A to O? Well, A to O is the opposite of what O to A was. And O to B is what we were given, position vector B to B. So that's just another way of writing it. You don't have to write both strategies, but I want to show you what it is that we're doing here. So what was O to A? That was vector A. So that was 5, 1. So we must take the opposite of 5, 1, because we're going in an opposite direction. And we add to it O to B, which was column vector 1, -3. So what does that equal? Well, that's going to equal A to B. The scalar -1 is multiplied through, giving us -5, -1. And we add that to 1, -3. That's not a fraction, Penning. That's 1, negative 3, and that equals negative 4, negative 4, column vector. There we have two ways of determining resultant vector A to B as a column. Okay, so at this point in our vector life, using the diagram and coming up with that resultant would be fine, but I think that you should now start looking at the vector equation and how we manipulate that, and it will definitely help you with questions such as this.